Okay, now this is the experiment that has been conducted. We have a meter rule, we have the meter rule, we have the knife edge. As you can see, this is just the setup here. This setup is what is on the board. Then we have another one here. This setup here is what is on this place. Then how do we get this one? We try to make this body to be at a point, this point here. Then we put our knife edge at this point, which is this. Try to adjust this one. When we adjust this one, there will be a point where this meter rule will balance horizontally. So when it balances horizontally, we mark that point and measure and subtract this 50 from this place. This is center of gravity. The body is here, constant. So we try to subtract this one from here, and that will give us this distance. This is the balancing distance in air. Then we put this body in water. When we put this body in water, in this form, and we put it in water, we adjust this body here, and this place is still at 50 constant. And we adjust that body, we are able to get this point. This point is this point here throughout for the whole regency here. We have these points. Now we subtract this one, subtract 50 from this point. That gives us all these points here. So these are the balancing distance in water. And this one are the balancing distance in air. So that is the experiment. That is the experiment. That is the experiment. So this is the results that we get from the experiment. This one minus this gives us all this value here. We now say this one, subtract this one from this point, and that's how we get balancing distance in water. That is all these points. Now this in air minus this distance in water gives us this one, and that's how all these ones subtract these ones from all this. That's how we get this point. Moment of a force. How do we get this moment? We say that this is moment is force times distance, 0.98 times y in air. All this 0.98 times all this term here. That gives us this one here. Now this point is 0.98. That's the weight multiplied by balancing distance in water. That's how we get this moment of a force in water. This is moment of a force in air. So that is how the experiment is. Okay, now this is the balancing distance in air. This is the balancing distance in water. You notice that this is 18 points. In air is 18.6. In water is 6. In air is this. This one is more than this point at this regency here. That means the balancing distance in air is greater than the balancing distance in water. The result shows that when a body is immersed in water, it experiences an upthrust, which reduces the weight of the body, causing the body to balance at a shorter distance, causing this body to balance at a shorter distance, and reducing the moment. You see the moment of a force also reduces. The weight of the body is reduced due to the upthrust, and the balancing point of the body also reduces when it is in water. So that is what this result shows. Then we can now be able to, okay, now we try to plot we plotted a graph of balancing distance in air against the reduction in balancing points. This one is difference here. This one minus this gives us this. So we plot this one against this one, and this is the nature of the graph we have just plotted. So you notice that the balancing distance in air, as it increases, as balancing distance in air increases, the reduction in balancing distance also increases. As this one increases, this one also increases. This indicates that upthrust reduces the weight of the body. It reduces the weight of the body in water by reducing the balancing points, and also reducing the moment of force. So that is what the result has already shown us. Well, now, how do we apply this one in a real life cases? In real life situation, this experiment shows that heavy objects are easier to lift in water than in air. That is the practical, this is the real life application of this experiment. People feel lighter when swimming than when the person is in air. These are the real life application of this experiment. Now, during this experiment, we took some precautionary measures. One, we avoided parallax error when taking reading from the meter rule. We also tried to avoid draughts. We avoided draughts. That is, the air resistance was also avoided during the experiment. And finally, we tried to ensure that the body did not touch any part of the beaker or at the bottom of the beaker. These are the various precautions we took during the experiment. This is National High School, Aba, in Aba South local government area. So we are here to conduct practical on physics. And my name is Vincent Ugoji. That is the physics teacher. So